All right, friends. Hope everybody's doing well out there. Today we're going to cover Chapter 2, Section 4, Problem 6. Let's go ahead and share our screen and get the party rocking. Um, oh, that's not what I want to see. All right, so uh, here is our assignment. So we just did, we've done 5, we've done chapter or section 2.3. We've got a couple left to go. Today this video, we're going to focus on number 6. Okay, so over here, I've got the book open and we're in, I'll show you, this is still section 2.4. And so now we want to do number 6. This one says we're going to list the first 10 terms of each of these sequences. All right, what worked well is this handy dandy little Excel spreadsheet. And so this is problem 6. So I'm going to call this term. Actually, we'll do this. I'll call it sequence, and we'll have A, B, C, D, E, and we'll circle back. And then this is going to be, now we can just drag this down here. Oh, too many. All right, so now we know what we're working with. I'll slide it to this side. Actually, we won't snap it. I'll just, I'm going to do something silly here. There. Okay, so that way we can have this screen up and this screen up, and you can hopefully both see all of this at the same time. Again, as far as the buildup goes, what is the question asking us to do? It is asking us to plug and chug some sequences based off of the word problems they're providing us. And a different way to say this is they're asking us to translate from kind of confused wording, mathematician wording for sequences down into normal numbers that normal people would use and understand. All right, such as obtained. I don't really, when I'm talking with my 5-year-old, my 7, I'm sorry, I've got 2 children, 7 and 3. And when I'm talking to them, we don't talk about obtaining things very frequently. When I talk to my wife, maybe if we're talking about using a grant to obtain some resources, maybe, but that's not a word that I use. So here's a sequence obtained by starting with 10 and obtaining each term by subtracting 3 from the previous term. So equals this term minus 3. 7, I like that. Should be 4, and then 1, and then, yep, as expected. Assume that we are allowed to use negative numbers in a sequence. So I'm good with that. I'm going to cheat just a little bit. This will backfire on me later. Make it big right quick so I can hit this button, and then I'll make it small again. And let me make that, no, not yet. It's still, yeah, there, it kind of goes. That's kind of working. Nope. Formatting is not necessarily an important thing, but I like to do it sometimes. Now we're on sequence B. Sequence B says the sequence whose nth term is the sum of the first n positive integers. So this is equals, now this is going to equals sum of those. So it should be 3, and that makes sense. 2 plus 1 equals 3 equals sum of A3 to A5 equals sum of A3 to A6. Well, let's see if this makes sense. So if you add 2 to this, you get 3, Add 3 to this, you get 6. Add 4 to this, you get 10. And we've got a pretty good pattern. Add 5, you get 15. Now, this is not something that Microsoft Excel has figured out how to do an autocomplete on, but I'm okay with this. Now, I'm sure that there are more elegant solutions, but I'm okay with this. Okay. All right, now we're moving on to part C. And it says the sequence whose nth term is 3 to the n minus 2 to the n. Okay, so this is equal to, oh, you know what? Keyboard power of 3 comma n minus power of 2 comma n, where a represents our n. Yeah, let's try that autofill. Let's go down to the third one because that's about as far as my brain can do. So 3 to the 3 is going to be 27. Minus 2 to the 3 is 8. So 27 minus 8 is 19. I'll buy that for $1. And so that's the sequence that it's suggesting. And I'm okay with that. All right, D. This is the floor of the root of n. So equals floor and now I've got to do power of n comma 0.5. Okay, so close that one and close that one. And I think the default behavior is round to the integer. And let's see if this makes sense. Okay, the root of 9 is going to be 3, because 3 times 3 is 9. And then 10 would be, yeah, that makes sense. And it won't be 3. Yeah, so I'll take that. I think that makes sense. 2 times 2 is going to get you 4, so that's when it'll jump up 3. And if we continued this on, I would guess that probably 16 is the next term where it'll go tink and go up. All right, so let's take a look at E. Question E, the sequence whose first terms are 1 and 5. Okay, so that's not too terribly weird. And its each succeeding term is the sum of the 2 previous terms. Equals this plus this. We'll autofill it. Let's take a look at that. Okay, so 1 and 5, 6 plus 5 is 11, 11 plus 6 is 17, 17 and 11 is 28. Yay! I'll buy that. I'll go with that. I don't know that that's correct, but yeah, I don't have anything better to go with. So I'm going to move this over on my screen now, and I'm going to roll this one down. So I've got F, G, and H. So I need to mark that out. F, G, H. Okay. And just because I don't have anything better to do, I'm going to fix the formatting. And by the way, center that line like that. Okay, now do you make this one skinny? No, it's still messing with me. That's hilarious. Okay, we are on sequence F. And here we have 6F. And it says the sequence whose nth term really? You got to get a chuckle out of these sometime. I think you do. I think that's just hilarious. All right. The sequence whose nth term is the largest integer whose binary expansion defined in section 4.2 has n bits. Write your answer in decimal notation. No. I'll get back to it. We'll circle back. I promise I'll be a good kid. All right. G, the sequence whose terms are constructed by sequentially as follows. Start with 1. I understand that. Add 1 equals this plus 1. And now it says multiply 1. So equals this times 1. Now we do equals this plus 2 equals this times 2 equals this plus 3 equals this times 3 equals this plus 4 equals this times 4 equals this plus 5, and we'll call that done. Okay, so if we start with 1 and then we add 1, we're going to get 2. Multiply that by 1, we're going to still have 2. 2 plus 2 is going to be 4. 4 times 2 is going to be 8. 8 plus 3 is going to be 11. Oh, yep, that's right. 8 times 3 is going to be 33. 33 plus 4 is going to be 37. Multiply that by 4, you're going to have 30 times 4 is 120, plus 7 times 4 is 28. So 28 and 120 is 148. Plus 5 is going to be 152. Okay, so that worked okay. And now we've got H. Please don't hate me. Okay. The sequence whose nth term is the largest integer k, such that k factorial is less than or equal to n. Okay. So if I do 1 factorial is going to be 1, and that's equal to 1. Now I can do 2 factorial, because 2 times 1 is going to be 2. I can't do 3 factorial, because 3 times 2 is going to be 6. So that's going to be 2, and 2, and 2, and now I can do 3. I can't do 4, because 4 times 3 times 2 is going to give me 24. So 3 is just going to finish me out. Okay, so there's that. All right, friends. Now, if you're lazy like me, you would say, whoops, I forgot about F. Really, Everett's probably not going to ding me. The work on that is probably part of an answer. It's the whole, doing the work on this problem is all 5 points. I can get more points by investing into things like anything. Like I could show Everett, hey, here's me writing a Java code to find these sequences instead of doing it in an Excel spreadsheet. More than enough bonus points. But, it's kind of like, I don't know if you all follow teacher memes, but anyway, there's one on the internet where the guy is pounding on the door and he says, you have to come out of there sometime. Why? Because it's almost time to go to school. I don't want to go. And he says, but you have to go. You're the teacher. Okay, let's see if we can work through this. It says the sequence whose nth term is the, man, I got to write this down. I'm sorry. I am old. My brain does not remember these things. Actually, I've got it here in the book, and this is just hateful. I am going to go in and I am going to highlight this. And I'm going to make a note, not part F. And I'm also going to go into your assignment. Oops, wrong button. Stand by. Make a note. Not problem 6, part F. There. Now, no one will ever have to suffer like you are. Okay, so this is our problem. And now binary expansion in 4.2. Oh, that's not as bad. Sequencer terms are constructed sequentially as F. The sequence whose nth term is the largest integer whose binary expansion has n bits. Okay, the sequence whose nth term is the largest integer whose binary expansion has n bits. Okay, so now that my brain is kind of slowed down a little bit and I read that we're just talking about how to expand numbers, how to convert numbers. Okay, so n is the number of bits. So let's do this. I'm gonna insert one left. I'm gonna do F, and I'm gonna do F base 2. Then I'm gonna say F base 10. All right. Hopefully this makes sense why I'm doing this here in a second. All right, so n is 1, so we've got 1 bit. So that's going to be a 1. Now we've got 2 bits. That's going to be 1, 1. Ooh, fancy. 3 bits. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 7. Shoot, I can math some days. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, hopefully we'll see a pattern emerge while we're doing this. So base 10 is going to be 1. This is 3. Okay, so 1 plus 2 is 3. 3 plus 4 is going to be 7. 7 plus 8 is going to be 15. 15 plus 8. No. 15 plus 16 is 31. I think I see a pattern emerging. Insert one left, and I'm going to just call this F cheat code. Okay, so 2, 4 equals this number times 2. And then I think this is going to work. Okay, so this will be 63, 127, 255, 511, and 1023. And so the cheat was basically, I knew that we were just doing, every time we add a bit, we're doubling the range. So I know if you've got 1 bit, you can do from 0 to 1 because you've got 2 numbers. For this one, you can go up to 4, or you can go up to 3. So it's 0 to 3, 0 to 7, 0 to 15, because this is how many numbers you have. Anyway, if you spend too much time staring at binary numbers, this will start to make sense. I feel like that was a dirty poll. I am going to take it back. Instead of making it not F, I'm going to make F bonus. All right, so I'll make that change here. problem 6, part F is, let's say that is 5 points bonus. Okay, so anyway, that was fun, but I have some serious doubts. So what I want to do is I want to come back here. No, wrong screen. Let's see if I can find this. Not the syllabus. Even answers. There we go. That way we can come down and 2.4, number 6. All right, we'll make this work. We will make this work. And see, this is what I mean. They're like, so 1, 3, 6, 10. These are called triangular numbers. We can use the formula in the table too. We can just keep adding the previous term, blah, 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 blah. They give better explanations here. All right, let's bring this back up. Okay, so here we go. A, 10, 7, 4, 1. I will take that. Yeah, ends on negative 17. Okay. So B is 1, 3, 6, 10, 15, up to 55. I'll take that. Part C is 1, 5, 19, all the way to, yay, I'll take that. 1, 2, 3. Yeah, that's kind of like what we got. And notice the note, it says there will be 2K plus 1 copies of K. All right, part E, 1, 5, 6, 11, all the way to 191. Cool. Now part F, 1, 3, 7, 15, 31, all the way down to 1023. Cool. G, 1, 2, 2, 4, 8, 11, 33, 37, 148, 153. I will take it. And now the last one, part H, 1, 2s, and a bunch of 3s. Cool. All right, friends. Well, hopefully that was entertaining to you. I had a good time. So as far as discussion on that goes, here's what I would say. Part 1, explain what they're trying to do. They're going to say, basically, you're going to take the word problems defining a sequence and translate it into numbers. So translate mathese into numbers that people understand. Hopefully that's not oversimplifying it, but in my mind, that's basically what we're working with. Now, as far as what the book gives you, the book is going to give you definitions of sequences, and they're pretty useful. You can go in and you can look at some of those if you're not familiar with sequences, but you could just say, follow the definition of the sequence given in each problem description. And then as far as part C, assumptions, assume that you're able to use negative numbers. Other than that, I don't see a whole lot of assumptions that we had to make. So what I would say is no assumptions identified at this time other than negative numbers are allowed. Part D, Excel spreadsheet like this works great. And probably what I would do if I was making my own notes, I don't know for sure how to do this in a Google Sheet, but there's usually a way that you can, instead of showing the numbers themselves, there's usually a way that you can show formulas. And so what I would do, I would come in here, I would just copy this, and then I would do paste special. What, you know what? I wanted you to paste special, values only. And then here, where's the show equations? Tools. Maybe view. Show formulas. Cool. Really? Anyway, the reason why I would do this is because I'm easily confused and often annoyed by my inability to understand these things. And so how I do these things, I would go ahead and demonstrate it like this. Um, just so that I could have something that I could understand. Oh, got a couple more. I don't remember what I was doing. I have no idea what we did on H now, so I'd have to go back and look at it. But anyway, this is how I would present my part 4. And then as far as part 5 goes, I would say we followed the definitions provided in the book, and we used a spreadsheet to help us with our arithmetic. And we were able to come up with a solution that made sense to us based off of the definitions and the formulas used in the spreadsheet. And conveniently, those happen to also line up with Bob. And back of the book is I sometimes call it Bob. So anyway, I hope this helps. Thank you all for your time. I hope you're having a wonderful day, and hopefully you enjoyed this little discussion on section 2.3, problem number 6. I've changed my mind. Part F is not, we're not going to nix that. We're going to do that as bonus. So thank you all for your time. Have a wonderful day, and I look forward to seeing you next time. Take care. Bye.